Good evening, students. Welcome to JET program. These are the free online coaching classes for exams like Polycet, Tsrjc, and SSC exams 2025. And as you all know, we are here for our chemistry session, as the name of the topic is already displayed before you. So, our today's topic is structure of atom. Okay, students. So what we will be doing, we will be doing questions related to the topic structure of atom. Okay. And you all will have to answer the questions in the chat box. Okay. You will get 20 seconds for answering the questions. Okay. And if you have any queries, please raise it in the chat section. We will discuss that. Okay. I hope everyone is ready. Quickly give me a thumbs up in the chat box, students. All right, I can see many of you have already joined the class. Come on, students. Okay, so let's start the session with our first question that says, which of the following is not present in rainbow? And your options are blue, green, red, and pink. The question is very easy. Quickly write down in the chat box. Hurry up, students. Your 20 seconds are running very fast. Which of the following is not present in rainbow? Blue, green, red, or pink? You have to tell the specific color which is not present in rainbow. All right, first answer I have got. Hurry up, students. I'll give you a few more seconds. Okay, students, the correct answer is option number 4, pink. Pink. Ganesh is correct. That is, pink is the right answer, students. As you all know, in rainbow we have 7 colors. That is Vibgyor. Just a second, students. Vibgyor. That is violet, indigo, blue, green, orange, Gyor. Okay, Y stands for yellow, orange, and red. These are the 7 colors of rainbow. All right, students. So pink will be the correct answer. There is no pink color in rainbow. Only violet, indigo, blue, green, yellow, orange, and red. So the correct answer will be pink. Next question. Speed of light in vacuum is, and your options are number 1, 3 into 10 ki power 8 centimeter per second. Option number 2, 3 into 10 to the power 8 centimeter per second. Okay. Option number 3, 3 into 10 ki power 8 meter per second. Option number 4, 3 into 10 ki power minus 10 meter per second. Speed of light in vacuum, students. This question you need to answer very thoroughly. Okay, students, see, just focus here. Focus on the units. Focus over here into the powers. Just focus on the powers over here. See, the options are very similar, but there is very slight difference. And this slightest mistake, if you miss by chance, then your answer will be wrong. First option is given 3 into 10 ki power 8 centimeter per second. Second option is 3 into 10 to the 10 raised to the power minus 8 centimeter per second. Unit is same. Digits are almost same. The difference is only there in power. Again, third option 3 into 10 to the power 8 meter per second. And fourth option 3 into 10 to the power minus 8 meter per second. Again, unit is same. Powers are completely different. Okay. So the correct answer for this question will be 3 into 10 to the power 8 meter per second, not centimeter per second, students. Okay. Meter per second will be the correct answer. Okay. Bhavna, you have written the right answer. Well done. Next question. I want everyone to answer the questions, students. Please make the session interactive. I want every one of you to answer the questions. Okay. The given number of wave peaks that pass by a given point per unit time is called. And your options are number one, wavelength. Option number two, wave number. Option number three, frequency. Students, there is a spelling error. Over here, it will be Y. Okay. And option number four is amplitude. The given number of wave peaks that pass by a given point per unit time is called wavelength, wave number, frequency, or amplitude. Your 20 seconds are already running. Quickly write down the answers. Hurry up, students. Excellent, excellent. Many responses are already here, but I want everyone to answer. Your time is still left. All right. Students, the correct answer is option number three, frequency. Oh, my bad. Wavelength is not the correct answer, student. The correct answer is frequency. Okay. So those all who have selected option number three, you all are correct. I can see maximum of you have written frequency. Honey, Ganesh, Harish, Vishal, Lucky, you all are correct. Okay, frequency is the right answer, students. Given number of wave that passes by a given point per unit time is frequency. Wavelength is the distance covered by one crest and one trough. That is the wavelength. Okay. Next question. Which of the following relation is correct? And your options are number one, V is equals to lambda upon C. Option number two, C is equals to V upon lambda. Option number three, V is equals to C upon lambda. Or is it option number four, V is equals to 1 by lambda? Which of the following relation is correct? V is equals to lambda upon C is equals to V upon lambda, V is equals to C upon lambda, or V is equals to 1 upon lambda. What is V, lambda, and C? If anyone knows, please write down in the chat box. Otherwise, I'll tell you that as well. Hurry up, students. You all are doing great. You all are answering correctly. Please make the session interactive and quickly answer the questions. Just a second, students. Okay, I hope everyone has completed. Okay, there is a dilemma between 1 and 4. First of all, let me tell you, V over here is frequency, lambda is wavelength of light, wavelength, okay, and C is velocity of light. Okay, students. So, what is the correct relation? Frequency is equals to wavelength upon velocity of light, or C is equals to V upon lambda, V is equals to C upon lambda, or V is equals to 1 upon lambda. Hurry up. As you all know, what is the relation? The relation is just lambda is equals to C upon V. Okay. This is the relation. What will be the correct one? From here you can find out, that is C is equals to V upon lambda, or V upon lambda is equals to C. Okay. The correct relation is C is equals to V upon lambda. Over here, C is speed of light, V is frequency, and lambda is wavelength. Okay, next one, the range of colors or wavelength covering red color to violet color is called the, and your options are number 1, emission spectrum, option number 2, absorption spectrum, option number 3, visible spectrum, or is it option number 4, line spectrum? Hurry up, children. Your 20 seconds have already started. Yes, children, let me see how many of you have answered correctly. Okay, Yes, you all are correct, students. The correct answer is visible spectrum. Well done. Every one of you have written the correct answer. Bhavna, Hani, Harish, Vishal, Raju, uh, Maha, Shobha, Satwik. Everyone is correct. Well done. Excellent, students. Keep answering like this, students. You all are doing excellent. Next question. Value of Planck's constant is, and your options are number one, 6.626 into 10 to power minus 27 joule second. Option number two, 6.626 into 10 to power minus 34 joule second. Option number three, 6.626 into 10 to power minus 34 urge. Or is it option number four, 6.626 into 10 raised to the power 23 joule second? Value of Planck's constant. You have to tell. Quickly drop your answers in the chat box. Explain this question. You have to tell the value of the Planck's constant. It is a constant means, oh, okay, Planck's constant, which is, its symbol is H. You have to tell the value. What is the value of H, Planck's constant? Have you understood? Who has asked? Okay, Satwik. I hope you have understood the question. There is nothing to explain in it. Just you have to tell what is the value of Planck's constant. Okay. Maximum of you are saying option number two. And yes, those who have selected option number two, you all are correct, students. Well done. Moving ahead, electromagnetic energy can be gained or lost in discrete values and do not and not in a continuous manner. This is given by, and your options are number one, Planck, option number two, Rutherford, option number three, Einstein, or is it option number four, Bohr? So you all have to tell who gave this theory. Electromagnetic energy can be gained or lost in discrete values and not in continuous manner. Who gave this statement? Planck, Rutherford, Einstein, or Bohr? Hurry up. Students, your time is running very fast. I want quick responses. Come on. Increase your energies. Done? Students, I hope everyone has done. So I'm revealing the correct answer. That is option number one, Planck. Okay. So those who have selected plank, you all are correct. I can see Ganesh has written planks, Honey, Satvik, and you all are right. Well done, students. Okay, next question. The spectrum given by emitted radiation is called, and your options are number one, absorption spectrum, option number two, visible spectrum, option number three, emission spectrum, or is it option number four, all the above? The spectrum given by emitted radiation is called absorption spectrum, visible spectrum, emission spectrum, or all the above. All the above is not possible? Yes. Oh, I can see someone is saying all the above also. I've cleared the doubt as well, given you one hint. Hurry up, students. Okay, the correct answer is option number three, emission spectrum. Okay, students. So for this question, the correct answer is emission spectrum. So those who have selected emission spectrum, you all are right. Next question. The path of an electron around the nucleus is called, and your options are number one, orbit, option number two, shell, option number three, energy level, or is it option number four, all? Hurry up, children. The path of an electron around the nucleus is called orbit, shell, energy level, or all. Okay. The correct answer is option number four, all. Okay, orbit is also same, shell is also same, and energy level is also same. Okay, Harish and Satvik, you both are correct. Okay, all will be more appropriate answer, students. The path of an orbit of an electron around the nucleus is called orbit also, shell also, energy level also. Okay, so the correct answer is all. Next question. Stationary orbits have fixed, and your options are number one, energy, option number two, radius, option number three, both, or is it option number four, none? Stationary orbits. Now, this is a common question. Use your logics, then I'll tell you what is uh, there, how you can do these kind of questions if you are confused as well. Right, students, as you can see, the question is saying stationary orbit. Stationary orbits itself means that it will be fixed orbit, right? So if it is fixed, then its energy will also be fixed, its radius will also be fixed. So the correct answer is option number three, both. Anything which is stationary, yes or no? It is fixed only, right? So, suppose it is just like a globe, right? It has a fixed orbit around which it can rotate. It has a fixed radius also. It cannot gain energy because that is, you can say, not an atom or a molecule. So, this is how it goes. Option number three will be right answer. Harish, Ganesh, and Lucky. These students have correctly answered. Well done. Keep answering, students, like this only. Okay, maintain the pace in the entire class. Next question. Okay. Which of the following is not included in Bohr atomic model? And your options are number one, stationary orbits. Option number two, energy of orbit is quantized. Option number three, elliptical orbits, or is it option number four, absorption of energy when an electron jumps from lower orbit to higher orbit? Which of the following is not included in Bohr atomic model? Stationary orbits, energy of orbits is a quantized, elliptical orbits, absorption of energy when an electron jumps from lower orbit to higher orbit. I hope everyone has written their answers. Let me check. The responses are very high, students. There is a dilemma between the options. Let me reveal the correct answer. That is uh, option number three, elliptical orbits. Okay. So those who have selected option number three, you all are correct. Moving ahead, which of the following is defect in Bohr's theory? And your options are number one, it could not explain the spectrum of in atoms containing more than one electron. Option number two, it could not explain fine structure of spectrum. Option number three, it could not explain formation of chemical bonds. And option number four is all the above. Defect in Bohr theory. It could not explain its spectrum in atoms containing more than one electron, could not explain fine structure of the spectrum, could not explain formation of chemical bonds, or all the above. Hurry up, children, hurry up. I am waiting for your answers. Okay, students, revealing the correct answer for this question, that is all the above. Option number four is the right answer, all the above. Next question. The elliptical orbits were proposed by Rutherford, Bohr, Sommerfeld, or Schrödinger. The elliptical orbits were proposed by Rutherford, Bohr, Sommerfeld, or Schrödinger. Okay, so the correct answer for this question is option number 3, Sommerfeld. Okay, option number 3 is the right answer, students. Next one. The fine spectra of atom is explained by, and your options are number 1, Rutherford, option number 2, Bohr, option number 3, de Broglie, or is it option number 4, Sommerfeld? Hurry up, children. Increase your energy, increase your speeds. You have limited time to answer the questions. Although you all are doing great, I am glad to see that at least you all are answering, at least you all are trying. Do not hesitate to write wrong answers. These are your practice session, students. You can be wrong here. And you can refer to your books also for as of now. Okay, I can see maximum of you are saying option number 4. So, fair. Let's check who is correct. All right. The correct answer is Sommerfeld only, students. You all are correct. Those who have selected Sommerfeld. Ganesh, Naveen, uh, Vangapalli, Shobha, Satvik, not Shobha, Satvik. And all those who have selected Sommerfeld, you all are right. Well done. Next one. Now this you have to tell. Okay, focus on the question. For a given circular orbit, number of elliptical orbits possible are, and your options are number 1, n, option number 2, n minus 1, option number 3, n plus 1, or is it option number 4, 2l plus 1? For a given circular orbit, number of elliptical orbits possible are n, n minus 1, n plus 1, or 2l plus 1. Okay, I hope everyone has done. Every one of you have answered the question, students. Okay, I'm revealing the correct answer. That is option number 2, n minus 1. Okay. Next question, students. Quantum theory was proposed by, and your options are number 1, Rutherford, option number 2, Thomson, option number 3, Planck, or is it option number 4, Bohr? Hurry up, students. quick, students. Who proposed quantum theory? Rutherford, Thomson, Planck, or Bohr? Your time is up, students. Let me check. Okay. All right. All right, students. The correct answer is option number 3, Planck. Okay. So those who have selected Planck, you all are correct. Let me see. No, not Rutherford, students. Option number 3, Planck is the right answer. Naveen and Honey are correct. Vangapalli is also correct. Vishal is also correct. All right, moving ahead, students. Next question. Quantum mechanical model was developed by, and your options are number 1, D. Broglie, option number 3, Erwin Schrödinger, option number 3, Sommerfeld, or is it option number 4, Heisenberg? Quantum mechanical model was developed by whom? These type of questions are very important, students. Please be prepared for your exams. Okay? Refer to our videos, older videos as many times as you can so that your practice can go on. Okay? You will not forget what kind of questions are being asked. There will be a quick revision also. All right, students? Okay. As I can see, maximum of you are saying option number 2. And those who have selected option number 2, Erwin Schrödinger, you all are correct, students. Well done. Okay, next one. The region of space around the nucleus where the probability of finding electron is called orbit, orbital, nucleus, or quantum state. The region of space around the nucleus where the probability of finding electron is called orbit, orbital, nucleus, or quantum state. Okay, the correct answer is orbital. Okay, the correct answer is orbital. Orbit is the path where the electrons revolve. All right, students. Next one. Shape of px orbital is spherical, double, or circular. Shape of px orbital is px orbital, students. Okay, there is a dilemma between 1 and 2. Students, the correct answer is dumbbell. Okay. Of s orbital is spherical. Of p orbital, it is dumbbell. So the correct answer will be dumbbell. SPDF. D is double dumbbell. Okay. Next question. Number of nodal planes for s orbital is, and your options are 0, 1, 2, or is it 3? Number of nodal planes for s orbital is 0, 1, 2, or 3. Okay, done everyone? The correct answer is 1. The correct answer is 1. Next question. Which of the following is not true for p orbital? And your options are number 1, shape is dumbbell. Option number 2, have one nodal plane. Option number 3, p orbitals are perpendicular to each other. Or is it option number 4, lobes orient in between the axes? You have to write only one answer. Which one is the right? Which of the following statement is not true for p orbital? Shape is dumbbell, have one nodal plane. P orbitals are perpendicular to one another, or no, lobes orient in the axes. Okay, revealing the correct answer for this question, students, that is option number 4. Lobes orient in between the axes. Okay, lucky you are correct. Well done. Okay, so this was the question. All right, students, that's all for today's class. We will meet again in the new session with new upcoming classes. Till then, stay tuned, and yes, do not forget to subscribe our channel, and please do refer to your friends and relatives also about JET programs so that they can also be benefited by these free online classes. Okay. All right, students. Thank you. Thank you so much. Bye bye, everyone. Stay tuned.